The major development era of modern electronics started off in the 20th century. After the two consecutive world wars, most countries faced economic downturn, hence pressure was put on scientists to improve world economies through scientific research, particularly in electronics. While all this development was happening around the world, Africa was still colonized, in which during the colonial era, most resources in Africa were not used to developed African economies, but as fuel for the developed world. Because of Africa's oppression and lack of integration globally, Africa is still lagged with regards to development. We are Team African E-waste. Welcome to the globalization of e-waste, an African perspective. Electrical and electronic equipment, which we will call EEE, particularly Information Communication Technology, also known as ICT, has played a significant role in transforming how society conducts activity. Globally, the access to ICT is increasing, although there is a divide between developing countries, which are mostly in Africa, and the developed world. This difference has come to be known as the digital divide. The digital divide is caused by several factors, such as affordability and EEE manufacturing capacity. Our study found out that most African countries have no EEE manufacturers. Therefore, most African countries import their EEE from Europe, Asia, and America. And within Africa, there are some intra-EEE trades. ICT is expensive to obtain and maintain. This has resulted in African countries opting for cheap EEE imports, which are usually second-hand products. Our analysis of EEE imports showed that the total imported EEE in Morocco, Uganda, Tanzania, Benin, Ghana, Liberia, and Nigeria amounted to about 1.9 million tons per annum. The imported EEE in Africa was 10 to 28% of the total EEE installed base. The values indicate the extent of the rate of increase in EEE imports into Africa, showing that at this rate, the EEE installed base in Africa will double every 10 years. Some of the imported EEE are second-hand goods which are about to reach the end of life. Our study showed that of the important EEE, about 10 to 20% was e-waste. This has led to the discourse of Africa becoming the dumping ground of the developed world and presents the problem of the importation of e-waste.
E-waste is one of the fastest growing waste streams in the world. The global production of e-waste was about 44.7 million tons in 2017, and this amount is expected to reach 52.2 million tons in 2021. Africa produced the lowest tons of e-waste, which was about 2.2 million tons. E-waste represents less than 2% of the landfill masses, but contains 70% of hazardous materials as heavy metals. The hazardous material in e-waste includes heavy metals such as lead, mercury, cadmium, tin, arsenic, and other compounds such as polychlorinated biphenyl, halogenated flame retardants, liquid crystals, and fluorocarbons. E-waste in landfills produces contaminated leachates which eventually pollute groundwater. Incineration of these e-wastes can emit toxic fumes and gases such as the burning of plastic in the e-waste, which releases dioxins. Most of the recycling in Africa is informal, and there's a lack of infrastructure to process and the general funds to handle this waste. Informal recycling has a lot of occupational health hazards as workers are exposed to toxic fumes, particularly during incineration. Although there has been global efforts to restrict the importation of e-waste, such as the Basel Convention, most legislation has not stopped the illegal importation of e-waste into Africa. Most African countries still import a lot of second-hand goods, of which some of them have relatively short lifespans. Most African countries lack the legislation for sound e-waste management. The flow of EEE is governed in principle by demand, and the generation of e-waste is a result of this. From this study, Nigeria, Uganda, Egypt, and Algeria generate the largest amount of e-waste in Africa, with Nigeria generating approximately 1.1 million tons per year. The category that contributes the most to the e-waste generated came from IT, followed by white goods, then consumer electronics. The penetration of computers and mobile phones in Africa has increased drastically in the last couple of years. The amount of imported e-waste relative to the amount of e-waste generated in Africa was between 3 and 15%, and as high as 40% for Ivory Coast. Although the recycling of e-waste in Africa is informal, it is well organized, such as in Nigeria. This study indicates that a large amount of e-waste generated is stored. Of the 3.3 million tons generated in Africa, about 1.9 million tons was collected, indicating a collection factor of 57%. Of this collected, only 1 million is recycled, with the remaining going to landfills. This represents a recycling factor of 52%. In the recycling process, materials either refurbished or dismantled for parts. The e-waste recycling industry in Africa provides a lot of jobs and sustains many livelihoods. The value of e-waste is passed down the material flow chain. For example, collectors may buy e-waste from consumers, and recyclers may buy the e-waste from collectors. The recycling job often involves stripping material and burning of unwanted material, which results in the release of dioxins, which don't only have huge environmental impacts but are also hazardous to human health. Exposure to metals such as mercury often occurs in the recycling sites. There is a need for better occupational health practices in the informal e-waste recycling sector in Africa.
A report by Lekgotla in 2015 estimated that the number of years to the depletion for proven gold reserves in South Africa was 39 years, while for platinum group metals it was 248 years, and this was in 2012. The African metal industry is the largest in the world, and South Africa is one of the largest producers of platinum group metals. Baxter in 2016 cited the decline in ore grades and aging of mines as one of the factors contributing to the South African mining sector's decline in productivity. We saw it making an aggregated net loss of 37 billion rands in 2015. Globally, metal mining reserves are dwindling, and disposed e-waste contains valuable material in the form of plastics and metals. We are mining metals unsustainably while deteriorating the environment because of our lack of metal recycling systems. African mines supplies metals to the developed world for the manufacturing of EEE. However, value is lost in the continent due to its lack of ability to recycle the metal fractions in e-waste. Most metal fractions or e-waste metal containing components such as printed circuit boards are exported to Europe and Asia for metal recovery. This study shows that in the disposed amount of e-waste per annum, the amount of metals were about 235,000 tons of metal. Iron was the largest amount at 44% of the disposed e-waste metal fraction, followed by copper at 19%, then aluminium at 11%. Gold and silver were 2.3 and 3.3% respectively, while palladium was less than 1%. The total value of metals in the disposed e-waste per annum amounted to 480 billion US dollars, with gold and palladium contributing 47 and 42% to this value. In Africa, copper and aluminium are generally recycled partially because of their large amounts as they are easier to access, while gold, silver, and platinum group metals are generally not recycled. The amount of indium, mercury, and cadmium generated was about 8,000 tons each per annum. The amount of metals in the dumped e-waste indicate large amounts of metal value and environmental impact, while the total heating value from the plastic material in the dumped e-waste was about 5,284 megajoules, indicating large energy reserves. Currently, the limitation of recycling e-waste in Africa is insufficient volumes to overcome the economies of scale and infrastructure in processing some of the metal fractions such as the gold and the palladium. Pyrotechnology is the traditional method of recovering non-ferrous metals as well as precious metals from e-waste in the past 2 decades. In this process, crushed scraps are burned in a furnace or in a molten bath to remove plastic, and the refractory oxides form slag with some metal oxides. The pyrometallurgical process has been applied in the treatment of e-waste by treating it together with other metals such as the Noranda process in Quebec, Canada, the Boliden Ronaska smelter in Sweden, and the Umico at Hoboken, Belgium. All these processes utilize integrated copper smelters and lead smelters, which have gas cleaners to reduce the emissions from the combustion of plastic fractions in e-waste. The plastic fractions in e-waste reduce the coke used in these furnaces. Africa has copper smelters in the southern African region. It is the recommendation of this study that upgrading of this existing pirate technology and building ones in Western Africa and allowing regionalization of dumped e-waste streams to increase the economies of scale by centralizing the processing of dumped e-waste in Southern Africa and Western Africa might be a solution. A solution while the world waits for cleaner technologies such as biotechnology to become feasible rather than leaving this material in dumps. Processing e-waste in Africa will not only reduce the demand from virgin metal mining in Africa, but also increase the amount of value chain in the African e-waste material flow.